Okay. Hello. In this video, I'm basically just going to be doing what I did in the live demo for the art workshop today, which was just make the lighter. As I'll talk about in the live demo, half of this is probably just going to be me actually doing like scripting, so visual coding, as opposed to making the effect, because in game development specifically, it's never enough to really just make the effect. You have to be able to know how to manipulate it at runtime through the use of coding in order for the effect to actually get its full value, right? And in bigger companies, you won't be the one doing this, so it'll usually be like a programmer that gets assigned to mess around with whatever you script and make. But in a lot of smaller companies, they just don't have the resources to do that, so you'll be given the task to basically script out your visual effects. And most of the time, it's very simple stuff. So like if you have no prior knowledge of coding, because I really don't have that much, you can still learn pretty quickly how to do these specific like tiny little things. So the first thing you want to make sure you do is actually get the lighter in the scene. This is the one that Connor made. You should be able to find it in the Discord channel if you don't have your own. But make sure that the body of it and the cap of it are two separate models, and then make sure you have the material of it set up. So how you set up the material, it's pretty simple. Your textures should come as like the base texture, like the base color, Normal goes into normal, and then depending on if you have an ORM, the red goes into ambient occlusion, the green goes into roughness, and then blue goes into metallic. But yeah, the first thing we're gonna do is click both of these and then create. You can't do it like that. Okay. So go to blueprint, blueprint class, actor, and VP lighter. So a blueprint is basically just like a script inside of Unity. That's the last thing I can compare it to. It's just what runs your code. So for this, the first thing we're going to do is add a bunch of components. The first one being static meshes, 2 of them. The first one is going to be our base, so that's lighter base. And compile, then lighter, here's our base. So that's the base right there. And then everything or every other component we add is going to be a child of this base, mainly just for positional stuff. Because since everything's going to be a child of this component, whenever we move the base, everything else will move following it, right? So it makes it a lot easier on our end. So another static mesh for the cap. It spawns in like this, but you're gonna have to do some rotational stuff to get it, because you want the cat to be closed by default. So that should be good. And it is a bit annoying trying to get it to actually be positioned properly, so that might take you a bit of time. Okay, I got it working. It took a bit of time, but if we're using the same model I am, then these location values and this rotation value will line it up pretty well. If you're using your own, it might take you a bit of time, but just make sure to line it up as closely as you can. And then for now, we're gonna set this to be invisible because we don't want this rendered unless we actually have our unless we actually are like using our lighter. We don't want any of this to be rendered. I'll also be setting this visible afterwards, but this is good just to have everything else positioned properly in the scene. So next thing I want to add is a point light, because it is a lighter, so it should be giving off light. That's the only reason why we add the point light. Point light will just, it's like fake lighting, but it's good enough for our purposes. If we're doing like a realistic lighter, you would want to position the point light like directly in here, but that actually does not give off good lighting, so try and leave it up a little bit. And then also, if you want the light to be like more going forward, you could place it like this, but that's kind of up to you how you want the lighting from your lighter to come. Like, also 50,000 I found is a bit too bright for a lighter. I would say somewhere around like 1500. It's probably good enough. An intention radius. This is basically just like how far your light like reaches out into the scene. So for this one, also 1000 might be a bit too big, so like 500 would be good. And then color, because it's like a fire kind of color, some kind of like yellowish color or yellow orangish color would work fine. You can kind of see it in there. But this as well is also going to be this hoodie. Yeah, we don't want this to be visible either until like the lighter actually gets turned off. Otherwise, we're gonna have like a really weird light source coming from the side of the player. And so then, this shouldn't be a child of the cat. This should be a child of the base. So the last two things we're gonna add are both Niagara particle system effects. These are again what I've been talking about, the Niagara system. These will be what hold our particle effects and everything. So we're gonna have two of them. So NS sparks, which will be like the lighter sparks when the lighter gets turned on. Position this. We can change the position later on when we actually get the effects, but like right here would be good for the sparks. And then we also want to add another Niagara effect, and this flame. What is it? Zero. And then this one, probably set it somewhere closer to like the base because the flame's gonna come out. So something like right there would be good, but we can adjust that later on. And then also for both of these, like everything else that we're setting to be invisible, we don't want it to always be active, so set auto activate off. So we'll be controlling when and how it activates through like the blueprints, so visual scripting. So, and then also turn this off. Compile, and then make sure you save a lot inside of Unreal because it can just crash randomly. So make sure you do save a lot. So a few more things that we have to do in here. We have to make two variables. They're both going to be of type Boolean, and the first one is going to be b is animating. This will be mainly for when we do like the animation part of it, like turning things on and off. If the lighter is already animating, so like if the player tries, pressing F, like spamming F to get the lighter to turn on and off really quickly, we don't want that because that'll like break the lighter. So we can only run our code if the lighter is already in like an animation state, which is what this will be used for. And then the other one is just a simple B is lighter on. Same thing, if the lighter is on, then we're going to turn it off. If the lighter is not on, then we're going to turn it on, and that's what the boolean is for. And then inside of the actual event graph, we're going to make custom events. Custom events are basically just events that you can call inside of other blueprints to then run a sequence of logic or code. So we're going to have one called turn on lighter, and then another custom event called turn off lighter. So yeah, we're gonna write all our logic for how the lighter should turn on stemming from this, and then same thing for how it should turn off stemming from this. So we don't have to do anything here for a bit. We'll come back to this blueprint when we have all of our particle systems working. But what we do have to do next is, since our first person, go to inputs and then actions. We have to create a new action so that we can like actually toggle on and off our lighter. And you can just call this one like IA input action toggle lighter. Open it up. Make sure that it is of valuable type digital bool, and that's all you have to do in here. Then go back to input. This is your input map. This is where you actually set all of your keybinds and mappings and stuff. So there's already 3 mappings. Want to add another one? Add it and scroll down, find IE toggle lighter, expand it more, and then choose. You can make it whatever key you want. I do F because I think F works well, so F, and then save everything. So now the F key is binded to this event called toggle lighter, and then the next thing we have to do is go into the first person blueprint. This is a blueprint that handles all your character movement and all that kind of stuff, and write some code for the F to actually toggle lighter on and off. But first, you want to make so go to viewport. This is how the first person camera looks. You just have the arms and stuff. But you want to go to select the first person camera, then add something as a child component to it of a blueprint. Is it called a blueprint? No. Alright. Let me find out what it's called real quick. Okay, yeah, so you're going to select the first person camera and then add a child actor to it. You can name this BP lighter because that's what we actually are adding to it. It's just the BP lighter. Compile so you can set the child actor class and search, and the child actor class search BP lighter. If I could spell. So yeah, now that basically sets the lighter as a child actor of your player movement script, and then you're gonna have to set this will take some experimentation on your end, or you can just follow like the numbers that I found work best for me. But you want to set this BP lighter to like be positioned where you want the lighter to like be when it's out, right? So like I have this like as a child actor of the camera because I have no idea how to like animate the hands properly. Also, you can probably just get rid of these. We don't need them, not for this instance at least. So like imagine there's an arm that brings out the lighter, and then position that where you think the lighter would end up, right? What I found the position to be that works well was 95 for the X, then -60 for the Z or the Y, and then -28 for the X. That's position that I found works well for me, but you guys can turn around and then come up with your own position, like location that you think works, right? Also, the Z rotation, put it to -50. Is it the Y? Oh, it's a Z. Wrong rotation. This will basically just rotate it to the sideways a little bit because currently, well, it's not visible, but currently when you play it up, it's like it's like horizontally straight to you, but you don't want it to be horizontally straight. You want it to be like tilted a little bit, and I found -50 is a good tilt for that, but you guys can mess around with it and change it. Also, to get to actually get this thing to spawn, or not spawn, but like so that you can actually see what it looks like. Go back to the where is it? Blueprint, and then just go back in here, and then just set all these to be visible again. And when you do, it'll actually like spawn in here, and you can see what it looks like, right? But for our case, I'm just gonna go with the values I tested beforehand, which is 95, 60, or -60 and -28. So that takes care of that. Now is the actual like the first time we'll do some scripting here. So you want to get a node, or in order to get these nodes, you just right click and it brings up the menu. You want to get event beacon play. This just calls when the game starts, and then from here you want to add a delay node. 0.2 seconds is fine. We just have to do this delay because we're casting to a blueprint, and if you cast to a blueprint right when the game starts, that blueprint might not have initialized yet. So in order to like stop it from getting a failed cast because it hasn't initialized yet, you just make a small little delay to make sure that it can initialize in time. And then also before we do that, we want to make an event dispatcher called, what was it called? Call lighter used. That'll be used for later. And also a variable called lighter reference, and this will be of type blueprint, I think. An object reference to it. Let me double check that really. Okay, yeah, sorry for that. It should just be, the variable should be of type BP lighter as an object reference. So you're gonna what do we do actually? So from the delay, before you actually like set or cast to the BP lighter, you want to get the lighter child actor over here and then drag into the scene as this as a get. And then from here you want to get the child actor, which is that blueprint, and then from here you want to cast to BP lighter, and then hook it up from here. And then the variable that we made, the lighter reference, in order to actually like set that reference to be this blueprint, you set, then just, yeah. And so now the lighter reference is actually holding a reference to this blueprint, and then we can change stuff inside of this blueprint. So that's how that works. Next is the input action stuff. So search up IA and then IA toggle lighter. So expand this value because we're not using trigger, we're using start instead. And the start gets connected to a custom event that we actually have to make right now. So the custom event is going to be called, alright, let's make the custom event first. Toggle lighter. So that's a custom event, and then from start we can just make it so that start just calls this lighter event. So whenever F gets pressed, it'll tell it to start this custom event, and then we can write the stuff for the logic for the custom event inside of here. So from here, I want to go into branch node. A branch is just, if it's true, do this, if it's false, do that. As for the condition of it, we want to get the lighter reference that we have, and then check if it's actually valid. Because if the lighter reference didn't get put in here correctly, then there's no point in doing any of this logic. So we just want to make sure that that's true first before you do anything. If it is true, then we want to use the event dispatcher that we made. Call it. Alright. That's a bit dumb. Just name it lighter beast. But basically, this tells this thing that the lighter is being used right now, which would be useful for it when you do all the other stuff. Then also from the lighter reference, turn call is like get is lighter on, because that'll be the condition for the next branch that we make. So kind of makes sense. Basically, if the lighter is on, you want, that's gonna determine like which event you call, right? So if the lighter is on, then you're gonna want to call the custom event of turn lighter. Alright. Unreal is a bit weird with its blueprint stuff, so you get the lighter reference and then get turn off lighter. Yeah, so if the lighter is on, then you want to turn it off, and then same thing with the other side, where if the lighter is not on, so if it's false, then you want to turn lighter on. And that's that. So yeah, that's all the scripting we'll do for now. But basically what we did was just very simple. We just set up during event begin play to cast to the BP lighter, and then set up some logic for it toggling on and off. That logic we will write later. And then also set the child actor, or set the lighter to be a child actor of the camera, and then inside the actual lighter we got all of our components down. And so now we'll actually move on to making the Niagara effects. Okay, so to make the Niagara system, let's go into our folder for Niagara. It's pretty simple. Just right click and then Niagara system, and then you want to say new system from selected emitters. These are all basically just a bunch of templates that already have like a set amount of modules in them to already achieve some effects. So like directional burst, if you set this by default, whatever system you make will be a directional burst by default. Then you have dynamic beam, that kind of stuff. A lot of the times you can just like pick one of these templates and then change the color or like change how they behave a little bit, and then to get like your desired result, right? So other times you don't actually have to like make your thing from scratch, but for the sparks we do have to make it from scratch. So yeah, just like that, and then finish, then call this ns sparks. This thing is very simple to make though. the first thing you want to do is just come into the system state, and then set the loop duration to be 1 second only, and then also to only do it once because it's a spark, it's a lighter spark, right? So we don't want the spark to be happening forever. And then call this one ns spark 1, because this will be the first spark that we have. We're gonna have 2. So the default material for this thing is fine, but the alignment, because we're going to be adding velocity to this later on, so we want it to be aligned with the velocity, so make sure you change that. And then from this, inside of particle emitter, we can, so this is how you add a new module to this group. And so the module we want to add is first, I can't spell, is it not shot? Yeah, spawn burst instantaneous. Now this will basically spawn a bunch of particles out of, like, as you can see right there. We wanted to spawn, you can change this number depending on how many like sparks you actually want it to spawn, but because it is a lighter fire, it shouldn't be too overboard. I think 20 is a good amount. So yeah, I set mine at 20, but you can make that less or more depending on how strong you want the spark effects to actually be. Also keep in mind, this is only the first set of sparks. We'll be making another set later on, so don't go too crazy with this yet. And then as for the color inside of initialized particle. Okay, so initialized particle, we want the lifetime to be random from 0.1 to 0.2, because like again, these are sparks, so you know they happen pretty quickly. We don't want it to last around forever, so you could do something like 0.1 to 0.4 if you wanted to be like a more of a stronger pronounced effect, so that's fine. Then as for the color, we want it to be a direct set, and we can come over to user parameters to then make a parameter of linear color. You can just call it linear color, it's fine, and then set the color to be something like an orange because like it's lighter sparks, right? So like an orange color is fine. I'll just drag that, right, and drag that into here to set the color of the sparks. The reason why we do it as a user parameter is just so that we can edit this setting inside of the editor instead of having to come like directly into here and then change its details this way. So that's linear color, and then you want to go to the sprite size mode, and then instead of that being unset, you want to do a random range float. We don't have that option, and non-uniform should have worked then. Actually no, random uniform, yeah, random uniform works. What values was good for that? The random non-uniform, these are non-uniform, I guess. Okay, so for the random this basically just sets the sprite size minus max, that way we get all our sparks are different sizes instead of the same size all the time. For this, 2 to 3 for the minimum is a good value or a good range, and for the maximum 6 to 10, because we don't want these sprites to be like too big, because again they are just other specs. So this is what I found is a good value for that. And then inside of particle spawn, this is where we'll add our velocity. So add velocity, just fix this, you're gonna fix itself for you, as you can kind of see. So now it's kind of going up, right, which isn't exactly what we want. We want it to be from a point and then go outwards like that, yeah. So for the velocity, a good velocity speed is so right click on this arrow. This will like let you select what kind of value you want it to be. For this, you want it to be a random range float. Random range floats you'll use a lot because in most particle systems, the more randomized everything is, kind of just the better it looks. So yeah, a random range float. And then for the velocity speed, it'll be from like 100 to 200. And so now you can kind of see the sparks are actually you know, doing like they're acting more like sparks. So that's that. And then inside of particle update, we're gonna add another module called scale sprite. I cannot that spell. Scale sprite size. Nope. There we go. Scale sprite size. This one might be a bit complicated. Okay. Scale sprite size. Non-uniform curve. So now we have a y curve and an x curve. You can set the y curve to not appear so we can focus on the x curve. For the x curve, the values that you want are 0, 1. This one's good. Or is this 0, 1? Yeah, so you want this one to start off at the top, 0, 1, and then to add another key, just add a key, and this key gets added. But for the second key, you want the values to be 0.2 to 0.275, and the last key is 0, 1, I think, or not 1, and then the value is 0. And then you want to select all these keys, right click on, and then put them as auto so that the graph has more of a curve to it. So that's the x done, and then now you want to select the y. And as for the y, it's gonna be, or for the y you only need 2 data points instead of 3. So for this one you want to do 0.2 to 0.2 and then 1, and then, wait, did I set? Oh, I clicked the wrong thing. Okay, 1. Yeah, so for this one you want to be 0.2 and then 1, and then for this thing you want it to be 1 and then 0. So that all this basically does is make it so that when they spawn, their size is like the biggest it can be, and as they move out, it gets the size gets smaller and smaller. So it kind of emulates Sparks a little bit more, right? I don't know if you can tell, but now they're kind of acting more like Sparks, because before, problem was the Sparks would stay the same size throughout, so they didn't really feel like Sparks. It just felt like blobs that were getting sent out, right? But now because they're reducing in size as they go out, they feel more like Sparks. And then we want to do the same thing with colors. So in particle update as well, scale color. For the scale color, we can scale the RGB and the alpha. For the RGB, you want to set this as a vector from float, I think. Yeah, vector from float. And then this value, again, we're going to do a float from curve. So for these values, it's pretty simple, just 0.2 and 1. Or no, the first one should be 0, 0. And we add another key. I don't know why key gets added all the way over there. Okay. The next one should be 0.2. And 1. And the last key is just 0, 1. Okay. That will mess it up, so there's the key. Can I just okay. This might be a bit, you can also just right click and then add a key that way to like position it better, but this one 0 and then 1, I think, right? Yeah, 1. Basically all this is doing is setting the color to be bright, setting the color to be have its like full brightness value at the start, and then slowly just dim out. And the alpha is pretty much going to do the same as well. And then for the alpha, we want just straight from float from curve. For this one, it's pretty simple. I think it's already set. So we want it to be 1, 0. And then for the next one is just 0, 0, yeah. this. No, okay, wait, hold up. Okay, yeah, my fault. That was dumb. Your first key should be 0, 1, and then your second key should be 1, 0. It's pretty simple. Just the alpha, like, it disappears as it goes out, right? So now we have this, which is pretty good. And then, yeah, make sure in your sprite render to set it to velocity aligned. If you don't, it will not look like this at all. But yeah. So that's all we need to do for this spark. And then now we can just select and then Control D to duplicate it. Name this one to spark 2. You can kind of keep most things in here pretty much the same. We're just going to have to add 2 modules and then change some of the things around. So for this one, we want to go to the lifetime, the initialized particle and lifetime again, and set the lifetime to 0.5 to 1, because these particles, they're going to stay around for a lot longer because they're the ones that are going to fall down to like emulate embers, like falling down the lighter. And then also for the sprite size, is that smart? No, it is. Yeah, we want these to be a lot smaller as well. So like 0.5 to 0.3 to 0.5, as well as 1 to 2 for the max. And then go to scale sprite size, and I think we're only changing the X in this one, so select your X. Your first one should be 0, 1, that's still fine. 0.5, 0.2. Okay, never mind. The size and everything should be fine, so you can keep that the same. All we need to do now is add the 2 new things inside of the particles update. Yeah, inside the particle update. So we want to add something called gravity. Yeah, gravity force. And set this like -2000, which is a good force that I found, but you can set it more or less, depending on what exactly you're looking for. Let's see. Yeah, you can kind of see like the embers and go down from there. That might be too small, so go back to initialize particle and set this to be like 1, 2, and then like 4, 6. Yeah, that's better values. You can kind of see this, like it sparks, right? Because these are the ones that are meant to go down. And yeah, okay. The last thing we need to add is in the particle update again, add something called scale sprite size by speed. And for this one, it's pretty simple. We can keep everything the same except for the max scale factor, which is 1.5 and then 20. Oh, that's why we set the sprite size to be a lot lower. Okay, sorry. Go back to the initialized particle and then 0.3, 0.4, and then 1, 2. Yeah. I think that's good, but you can always like mess around with these settings to make it more as what you want it to feel like. But that's all we need to do for sparks. If you wanted to, you could also just add another spark emitter and then have like 3 different types of sparks that are going off. Completely up to you, but this works for the lighter. Okay, so next we're gonna make the actual flame of it. So again, just right click, create Niagara system, and then for this one you want to not select the empty but instead the fountain. This is the closest thing we can get to like a fire thing, and this will be our emitter source that we put for the Niagara fluid simulation. So just call this one ms flame, and you'll get to here. So yeah, you can kind of see that's what the fountain does. But so the things that we need to edit inside of here, the first thing you want to do is change the sim target from CPU sim to GPU. The fire itself will be a very, very heavy thing to compute, so in that case you would want it to be computed from the GPU instead. Also, so you don't kill your PC. Then we can go over to spawn rate. We don't need it to be 90 because we're getting like a single fire, so like 10 is more than enough for our case. Alright, we can make it 50 just to get like a stronger flame effect, but this will kind of control how strong the flame effect lasts. And then also inside of initialized particle, the lifetime, you can just set it to be a direct set of 0.1. Or you could do random and do something like 0.1 to 0.3. Basically, the bigger the difference is between these two values, the wilder your flame will look, like the more it will move around and stuff. But since we're doing a lighter flame, it shouldn't be moving around too much, which is why I have it set to like such low values. But if you want like a really, really strong flame effect, then you could just set these values to be like higher, so that way it'll seem like it's moving around a lot more. The next thing we need to do is first of all, disable gravity, and then also, well, this normally does have collision enabled with it, but we don't need collision because it's a lighter. The collision is more so for like when you're making a fire, right? Like a campfire, and then you put a log, so then you don't want the fire to be going through the log. That's what the collision would be for. But since we have a lighter, we don't have to really worry about that. Yeah. So the next thing is the shape location. Instead of a sphere, we want it to be a ring/disc. This kind of controls how many different like fire sources we have. Like each one of these different balls would become its own like ring of fire essentially. For a lighter, we don't really need that many, we just need a singular one. So that's all we're gonna do for that. And then the distribution, we want it to be uniform. And 1-on-1 is fine. The uniform is basically just so that like the fire just doesn't go off randomly because it didn't like say to have something there, right? It's just like a fail-safe. The next thing is the velocity, or does it not have? Oh, no, it does have velocity. Yeah. So the velocity, we want it to be a random range float. That's good. Velocity is another thing that you can customize yourself to like kind of give the basically the stronger you want the flame effect to be, the higher you want the velocity to be. I don't really need it to be that strong because it is a lighter again, so 30-50 works for me, but if you want a stronger flame effect, you can set these values to be higher. And then disable the gravity force, yeah, we did that already. And then the last thing we need to do inside of here is add inside of, I think, particle update, yeah. Fluids, gas source. Yeah, so like I said before, this fountain will be the source that the gas comes from, and the gas is basically what's going to act as our flame. If you don't see this when you do plus, make sure you go to edit, plug, and then search Niagara, and then make sure you get this fluid activated. Otherwise, you're not going to see anything else that I do from here on. But once you get the fluid's gas source, you want to set the density to be 0.5, 6, and then the temperature to be 0.95. You can change these settings however you want, but just make sure to keep the temperature really, really low. Otherwise, you will just get flashbang because the color of it can't get very bright if the temperature is set to like even 1, right? So just make sure to keep the temperature value low. The density and the radius is kind of just like how big you want the flame to be. I found this value works well for the lighter case that I'm using, but if you want the flame to be like bigger size-wise, then you can change these around, obviously. So now your fountain's done, the next thing you want to do is our add emitter and search for grid. Yeah, so go to parent emitters, grid, and then grid 3D gas master emitter. This will allow your PC when you put it down, because as you're about to see when it's done compiling, it's a very, very, very strong effect. Never mind. Yeah, it's very, very strong, right? So in order to save your PC, just pause it. We don't need this to be playing while we're like actually editing it. That will just kill our PC. So inside of here, the first thing we're gonna do is set the bounds to be a lot lower, because we don't need it to be going up that high, especially for like a single leg, right? These bounds work. Also get rid of draw bounds, otherwise you're gonna see that red circle inside your actual game itself. And then the max resolution size, set it to be 160 by 4, because we don't need it to be high resolution since it is purely just going on a lighter. That will save us some performance. And then in the initialized particle source, we want it to be an emitter. and then emitter name. We don't want this to be the source, we want our fountain to be the source. So come here, F2, copy it. Make sure that the name is exactly right because it is all case sensitive and stuff. So fountain, and then it should be compiling. Oh, not good. Also, we can turn the sprite renderer off, as well as inside of here, inside of sourcing, we're looking for a disable. We need to disable some stuff, but where is it? Okay, now just click back into here. Maybe that's why. Sourcing. Okay, I'll just click back in here and then just search up, search bar, just search grid 3D gas sphere. I wonder why I don't see it. Okay, let me pause real quick. Okay, so yeah, what we actually want to look for was just click again here and then just scroll down until you find this sphere source and then just select disable that. So now we actually get like a much more flame kind of effect going on here. And then the other thing you want to do is search up curl, and then this compute curl, you want to disable that as well. So yeah, now we kind of have this, right? But this isn't really like a fire kind of a thing. And the way we get it to be more fire-like is by going into, again, so you want to have the emitter selected, and then you want to find the attributes. Where is the attributes? Attributes right here. Check the temperature on. When you check it on, you'll see it's picking up the color that we set earlier inside of this right here. That's why I said like set the value to be low, because this is a very low value and you can already see it's very bright. So when I set to 1, it will just flashbang you. So make sure you keep that value low, right? Then the two other things that we need to set are the dissipation rate density and the dissipation rate temperature. These two things basically control how big this like one plume of flame is. You can play around with these settings and like check what attributes you like what values you like for these. But the ones that I tested and found that I thought were good were 15 and 6.5, which get you something like this. And so that's the flame done. That's what I like. But obviously you can like change these two values around, change the temperature around, change the velocity of spawn rate to kind of get the flame to be more as what you like. So yeah, that's the flame lighter done. Okay, now this is a long video, but I promise you're almost done. We have everything we need. Now all we have to do is just put everything together and get it animating, right? So inside of Sparks, you want to come here and then obviously you want to add the Sparks that we made. Just for like visual effect, you can activate it to be auto activate. So but yeah, if you want to like actually see it with the lighter there, which actually probably is a good habit to test it with, to actually like have this on. I can just leave it off because I've already done all the testing before, but when you're doing it, you should actually have the thing turned on. So like, yeah, the position for it is good, but normally for this, you just want to be testing the position of it. So yeah, the position is good. Just keep, make sure you set this to be false by default. Then next is a flame, which I'm a bit scared for because it will lag your PC out a bit when you first put it in. And then flame and then auto activate. Maybe I messed up somewhere. There's flame. There's a collision inside of here, so I don't know why it's getting collision. one thing we could do to solve it would just be to set this to be like 0.75, so that way it shouldn't be cutting with it anymore. I'm gonna just put it like another point. That is weird. Oh, maybe it's a lighter that has this thing that has collision. So search collision on here. Collision, no collision. Can I fix it either? Okay, well, let me figure out why that is not working. Okay, sorry about that. I found the problem. It was a collision thing. So make sure that you have no collision on both the base and then the cap, and then the fire effect should work pretty fine after that. Also, because it is clipping out a bit, as you can see. Just like reduce that a little bit. It's like 0.75, and then you won't do that. But you want to set the thing inwards. So this is like really strong for a light effect. Might even be a bit unrealistic, but you know, for a portfolio piece, this actually works really well. Also, because this is like an experimental feature, it is hard to actually get this working in a game. You have to do a lot of special like building, like when you actually go to build the game, you have to make sure that you like go to the engine and set this to actually be like built within the game, otherwise it won't build it. So it's not impossible to have this running inside of the actual game itself, but it is a bit hard. So I would mainly recommend this to be used more as a portfolio piece as opposed to like an actual thing you want to use inside of the game. But yeah, and then we can set this to be non-visible again. Okay. So compile, and then now we can actually get to the scripting part. Okay, so from turn on lighter, the first thing that we want to do is get a branch node, I believe. Yeah, so we get a branch node, and then the condition for this that we want to check is animating. So just drag that, get it, set that to the condition, and then only if it's false, because we don't want to actually do any of this logic if the lighter is already being animated. So then from false, the first thing you have to do is again get this, but set it to be true, because now it is animating, right? So that's the only way. So we have to do this for both of them. So now that it's set to is animating, the next few things are going to be pretty simple. It's just set visibility. Set visibility for the lighter base. This basically just says, okay, since light is turning on, now let's make the actual lighter itself visible. And you can just duplicate that, turn that on. So I'll put for this one, instead of the base, you want it to be the cap. The light will turn on later down in the logic. But from here, the next thing I want to do is get a timeline. So a timeline, we can call this timeline underscore lighter move on. The one thing you want to do is make sure you do play from start instead of play. That's really important. So you can double click the timeline and open it, and then you can add a track, float track, and just call this float track move track. The move track itself is actually really simple. So you can right click and add a key. For this key, you want it to be start at 0, 0, and then you right click to add the second key. For this one, we want it to be 0.65, because that's how long this like moving it to the front of the camera should last, and the time or the value is 1. So that's all we need to do for this. If you want the animation to feel like a bit smoother, you can just do it auto, so it's more of a curved value exchange thing, but that works fine. So then compile, go back to your event graph, and then from here, what you want to do is get something called a lerp, just specifically a lerp vector, and move. I said the move track to be the alpha. Basically, all this does is, so if the alpha is 0, then it outputs this value specifically. If the alpha is 1, it outputs this value. If the alpha is like 0.3, then it finds the 0. Like imagine as like a number line, it takes the values you would get like 0.3 in between these two and then outputs that, right? That's like the best way I can explain it. But basically, because we have this timeline that goes from 0 to 1 over 0.6 seconds, it'll go from this value to this value, like numerically, over 0.5 seconds, which is how you get the animation, right? As for the values of these, B is what you want it to be when it's at the front of the camera. So we set the actual, like, I don't know if you remember, but all the way at the start of the video when we actually set the location of the of the lighter inside of the player blueprint, that's the location you want it to be here. So for me, that's this location, but if you decided to position the camera elsewhere, make sure you input the location that is inside of here. Okay, right there. Make sure you input that location. And then for the A, regardless of, or in order to test which values are good for A, just like take this and position it off camera, like so, like to the side over here, so that way it like goes up. This is the animation basically, right? For my case, what I found was a good value was to be, let's see, where did I write it down? -8, -11, and then -47. So now we have this, right? And then from the updated part, we want to set relative location for the lighter base. So that's the target. This is just setting the location of this, the lighter base, and the new location should be this, right? So this is how the animation works. It's really simple, and we basically just do the same process except for the cap to like make the cap turn on, right? But before we do that, yeah. So next is we have to do a delay because we don't want the 0.7, because we don't want the timeline for the cap animation to start playing while this timeline hasn't finished, right? So 1 second. Okay, so the next thing that we have to do is, so for right here, we basically just animated the lighter cap. Not the cap, we basically animated the light itself going from like our pocket or something to directly in front of us, right? And so then we have to have this delay here so that the next timeline doesn't start immediately afterwards. So this delay is basically saying wait until this timeline is finished and start on the next time. The next timeline though is going to be the timeline we use, let me see, for the cap itself. So timeline underscore cap flip on, and then same thing with this one, you want to play it from the start, not play it from there. Also, the reason why everything's play from the start instead of play is because play works fine when it's the first time you do it, right? So like the first time it happens, but then it doesn't reset. So like this one, it'll go from here to here, right? And then it won't reset. So the next time you call this animation, it'll just be stuck here, which is why you want to play from start to make sure that it resets properly and goes back from here. So for most of the timelines you ever make, you do want it to play from start, unless it's a very specific thing where like it doesn't matter where the timeline, like if the timeline resets or not. But yeah, that's why we do it from to play from start instead of just play. So yeah, in the timeline flip, same thing. We add a float track. We can call it. What do we call it? We can just call it flip track. And then for the values for this one, add a key. Value will start off with 0 and yeah, so 0, 0. And then add another key. For this one, the time will be 0.1, but the value will be 0.8. That doesn't seem right. Hold up. Okay. So yeah, the second track should be 0.1 to 0.8. Then we got another key. For this one, the time for this one is going to be 0.15, and the value will be 0.15. Oh, hold up, these values seem wrong. Okay, yeah, no, I was just tripping over nothing. So yeah, your first value should be, the time should be 0.1, and the value should be 0.8. And then for this third key, same time 0.15. For the value, however, the value should be 1. And then you want to add a fourth key with the time being 0.2 and the value being 0.8. And then you only want to select these two and then set theirs to auto. You can keep these as being linear because it's meant to be like a very snapping motion, right? So linear actually works well in this case because you don't want the flipping to be like a smooth, but more so like a snap. And then back in the event graph, from the flip track, similar to right here where we pulled a vector node or a lerp node, we're going to do the same thing, except this time the lerp node will be a lerp rotator, which basically the same thing as this, but instead of a vector, you're using rotation. As for rotation, it should be -70 to start. This is a rotation, or if you're using Connor's slider, it'll give you this is a rotation that it needs to be closed. Yeah, so -70 to be closed. And then the new rotation should just be, what is it, 80? Almost like a full 180 rotate, but you want it to end off slightly more. So 80 works well for me, but obviously you can use different values depending on what kind of animation you want necessarily, but these values work well for me. Then from this, you pull the update and then you set relative rotation on the lighter cap. Yeah. Then you plug this value in for rotation, and this entire part is basically what does all the animation. It's really simple. Timelines are your best friends if you want to do animation without actually having to do any animation. Yeah, so all the animation part's done. Now all that's left to do is to do the particle systems. So from here, you want to get another delay. Delay is 0.4, basically so that the particle effects don't start playing while the animation's still playing. Then from here, you want to get an activate node, and then you want to activate the sparks. And yeah, you should mark it as reset. So basically, we activate it, and then it'll reset its value after it's done being activated, right? And same thing, get another delay. For this delay, you want it to be 0.6 seconds. Reason for 0.6 is because that's how long one loop of this thing takes about. So you want to let the first loop finish, and then you want to play the sparks again, just because like you could only have it play once or twice or 3 times, however many times you want. I like 2 because it's like you flicker the light once, it doesn't turn on, then the second time you do it, it actually turns on, right? Which is why I'm doing it twice. So this is the activate, and then after that, it's gonna be another delay node because now you want this thing to kind of finish before you start the next one. But for this delay, you can just put it to be 0.3 seconds. All these delays you can change to get different effects, but these are just the numbers that when I was making it, I found useful for mine. Then same thing, you want to do another activate, but this time you want to activate the flame. Also reset it, and then from the flame, so then after the flame comes on, then you want to do set visibility again, but for this time for the point light that we have, so that after all this, the point light actually gets activated, and now there's going to be light coming off from the lighter. For this one, you also want to set new visibility. And then from here, the last 2 things you have to do are set our 2 variables. So set is animating to be false because now our animation is done, so we can reset that state. And also is the lighter on. You want to set it, and you want to set it to be true because now the lighter is on. And that's all the logic for turning the lighter on. Turning the lighter off is really, really simple. It's basically just this entire chain of logic, but done in reverse. So to start off with, well, we still need this part right here. So you can just duplicate that, like select everything, Control D. Because we still need to make sure it's not animating, and then set the fact that it is animating. But after that, we want to deactivate our flame. The flame is the only thing you have to deactivate, by the way, because for the sparks right here, where are they? The sparks are not set to loop infinitely. They play once and then they deactivate themselves, right? Alright, I forgot to reset this. But with the lighter, like the actual flame, it's set to constantly be active, which is why for this one you actually have to deactivate it. And then, so you deactivate this, and then after you deactivate that, you want to set the visibility of your point light to be not visible anymore. And the way you set it not visible is you don't check your visibility, because once the flame's gone, the light should also be gone, so that makes sense, right? Then you want to add a short little delay, 0.2 seconds works again, and then from here you want to call your sparks again. So activate sparks, I reset it. This is so like, okay, the light's gone out, and then it gives like one final spark, right? That's also what we're doing too. And now we do the animations, but in reverse. And the way you do it in reverse is quite literally, so we do the cat flip first, right? You got the cat flip, you control D, you can name it timeline cat flip off, and then you just reverse from end. It's just that simple. And then you can just copy this whole logic, paste it in there, plug in the update, and then plug in the flip track, and it's the animation goes in reverse now. So you have to do for animation. And then same thing, what was the delay here? 0.4 seconds. Okay. So then you want to add a delay node, because this takes 0.4 seconds, or actually no, the animation, the reason why it's 0.4 here is to like give time for the spark thing, but we can just keep this like 0.25, that'll be good. And then same thing, we have the lighter move, you duplicate it, call it lighter move off, you reverse from end, and then copy all this, put the update in there, and then put the alpha over here. And that should be everything for the animation. So now your lighter is completely gone, but you still have to do some more stuff. So in delay, 0.7 seconds again, because that's how long that animation takes to play. And you can just copy this node, or these couple of nodes, paste them there, but just set the visibility to be off instead. And then get these two variables, put them in right here, and well, it's not animated anymore, so we set that to be false, and the lighter isn't on anymore, so we set that to be false as well. And that's all the logic you have to do. So like logic wise and scripting wise is all pretty simple stuff. It's not really that complicated, it just takes a bit because there's a lot of it. But now we can actually go and test out the lighter.